analysis. You lucky devils are going to get like 5 lessons in a row today of me, which, you're probably not going to watch them 5 in a row, but still, here I am recording for you. So let's see. We got chapter 1, lessons 1 through 4 review. Oh, I'm going to read through real quick just an outline of what happened in each of the 4 lessons. And then we're just going to do a whole bunch of sample problems to prep you for your Delta Math quiz. All right, so here we go. Lesson 1, functions versus relations, right? Every set of points is a relation. Some are functions. That's when you have an x value that only has one matching y value. So x values don't get repeated, right? Then we were identifying, so we needed to be able to identify between all of our different types of functions and relations, the main ones, lines and absolute value and cubics and cube roots and I already said absolute value, and parabolas and circles, and we're looking at square root functions versus square root relations. Those were some of the things that we need to be able to identify between, right? Step functions, piecewise functions, the good stuff. Domain and range. So x values being used are your domain and the y values being used are your range. So you had a couple of little matchy activities for those guys. They should be in good shape. And one-to-one and onto functions. So they have to be functions in the first place, which means they cannot have a repeated x value. And then one-to-one functions also can't have a repeated y value. So a y value can't get used more than once. And onto functions mean the whole range has to get used. So if you have a function that doesn't touch some of your y values, then it's not an onto function, okay? Like a parabola, like an absolute value. Those would not be onto functions. Okie dokie. Well, a nice little review of all that in this box here, but let's go. Let's do some examples, right? So let's see, we've got a point here and a set of points, so it's a relation. We are asked, determine if the following relations are functions or not functions. Okay, so everything's a relation. Cool. So we're just going to write function or not a function, whether it's one-to-one or not one-to-one, whether it's onto or not onto, and then list the domain and range. Okay, so this line will be function or not a function. That's line A, right? This, let's just take a peek, is not a function. So this is actually really nice. We've got a repeated x value right off the bat. So not a function, NaF. Fun fact about that, that's sodium fluoride, right? Toothpaste, for those of you who are in chemistry. Next. Well, wait a minute. If this isn't a function, can it be a one-to-one function? No. If it's not a function, it can't be one-to-one, so not one-to-one. And if it's not a function, it can't be onto, so not onto. And there you have it. So now it's domain, since it was a list of x values, you can list x values, so -7, 0, and 7. And its range is -7, -1, 0, and 4. I didn't have to go in lowest to highest order, but I did because it was there. All right, next. Is this a function? Let's look at my x values. This is a function. Okay, is it one-to-one, meaning the x values don't have any repeated y values? Oh, wait a minute. This is all the same y value throughout. So since this is all the same y value throughout, it's not one-to-one. Okay, we've repeated our y value. We can't repeat our y value for one-to-one functions. It also means since it's a repeated y value, pretty sure I'd say it would not be onto because we don't have the whole. No, you know what? That's the listed range. We can be onto here. This one isn't as clear. We could be onto because it's only a list. It's not infinite. So since it's just a list and we used everything in the list for the range, we're good. We can be onto. So the domain, let's see. Negative, right in order, so that's cool. Oh, no, that was regular too. There you go. List them out. C. I do not see a repeated x value, so that would be a function. Let's look at y values. Any y values repeated? No. So this is also 1 to 1. Cool. And we did use all of the range values set onto us, like I said on the other one, so we'll also say onto. And now your domain, just list the x values. You know what? I'm not going to care that they're in order or not this time. And the y values. No repeats. Cool. Okay. Uh-oh. Repeated x value, which means this is not a function. That means this is not 1 to 1, and that means this is not onto. So if it's not a function, it can't be the other two anyway. So if you write NAF or not a function, then that's what's going to automatically happen. Now domain, list them out, and range. Okay. Oh, so here's a place where, start. This is a function, so that's good. No x values repeated. Function, plural, non-plural, singular. 1 to 1. No y values are repeated, so it is 1 to 1, but it is not onto. And the reason is, in this bubble for the range, I have a value in there that is not being used. So since this u is in here but not being used, this is not an onto function. Not all of the range is being used. All right. And so now I list the domain. And since they were just listed, I can just list. But we're not using u, so it's just v, w, x, and y. Okay, we did not use the u. Over here, however, if you look, this is a function. B, not 1 to 1, because you have a c repeated. You have a y value repeated, so this is not a 1 to 1 function. But you are using all of your listed range, so it is onto. So your domain is, of course, 1, 2, 3, 4, 5. And your range is A, B, C, D. There you go. Okay. Mapping, tables. I really should have just done one of each of these so that was a short video, but gets you ready. Gets you ready for your quiz, right? So here's a function. It is 1 to 1, and it is onto. So you're good. All those things are happening. Domain is 1, 2, 3, 4. And range is -2, 0, 1, and 3. That's what's getting used. Okay, this is a function because there are no repeated x values. However, it is not 1 to 1 because there is a repeated y value. And it is onto because you are using the full range that is listed in the map. So let's just list out our pieces for domain and list out our pieces for range. And you're good. This is a function. It is not 1 to 1. It is onto because we are using that one range piece that is listed. And I'm just listing right there. Once you get into it, right? Once you get into the groove, these are like super easy, super quick. Okay, check down the x's, it's a function. Check down the y's, it's not 1 to 1 because a 0 was used more than once. And we'll say it is onto because we are using all of the listed range pieces, right? So domain, just list them out. And range, just list them out. Again, as long as you have them listed, they don't need to go in smallest to largest order. That's just a, organizational piece for me. That's just kind of how I work. All right. Over here, not a function. So it's not 1 to 1 and not onto. I don't even have to look. If it's not a function, right? Got two repeated x values. So where are we going here, right? If it's not a function, it's automatically not one-to-one and not onto. I don't even need to worry about anything else. That's actually a kind of nice way to look at it, right? Here's a function again. It is one-to-one. It is onto because it's doing everything in the range, right? So we've got our domain and our range. Just listing off. Those are so easy because you're just listing, right? Not a function, so not one-to-one, not onto. Done. Domain is just -4. That's what's making it not a function. Only that x value being used. And this is your range. Okay. Lots of stuff you learned prior to now, right? Ooh. Okay, I'm going to do a couple of these. These take a little bit of time, but they're good stuff, getting you ready, right? And then we'll do some evaluates because most of the quiz is these evaluates here. All right, so let's get a couple of these done. So the A, B, and C are still the same as what they were before, right? So this is a function. It is one-to-one, and it is onto. And how you can tell it's onto with a graph is think of a graph as being infinite in both directions. So if your y values are going to repeat forever, if you are going to cover all of the y values with this particular graph, it gets to be onto. Okay? If not, it's not onto. So your domain here is all real numbers, and so is your range. And that's all we have to put for the inequality side. You can just put all real numbers. But for the interval side, the way you would write that is -infinity to +infinity. And that's the same for both. Infinity always has parentheses on it because it's an open concept. There's not one last number, not one first number. And so because of that, it's an open concept. We do the open parentheses. And of course, this is a linear function, also known as a line. You know, the word line is in the linear function, so hey, you got it. We have to keep track of my mugs. We're on Yas Queen, obviously. And this is Cleopatra. Okay. Ooh, not a function. And since it's not a function, it's not one-to-one, and it's certainly not onto. So not something I need to worry about a lot. But I look at my x values from my domain. No x values over here being used. Lots of x values over here being used. So what's that first x value being used? That's 0. So x is greater than or equal to 0. Interval notation. The lowest x value being used is 0, and it's being used, so it gets a hard bracket around it. And then it's going on to infinity, and infinity, of course, being an open concept, gets the parenthesis around it. I love interval notation because it's always just the smallest comma largest as far as your two numbers go. And then if you're allowed to be that number, you get the hard bracket, the closed bracket. If you're not allowed to be that number, you get the open parenthesis. So it's like the closed circle versus the open circle, right? Closed dot, open circle. I like to use those words. The range, of course, is all real numbers because it's just increasing in y values in both directions. So since it's all real numbers, that's -infinity to +infinity and parentheses on each end. Type this is a square root relation, not a function. So we'll just call this a square root relation. Right? Those parabolas on their sides, those are square root relations. Hope you know what C is. It's a circle. It is not a function. So of course, it's not one-to-one and not onto. And I mean, that makes sense. You're not using your entire domain. You have limitations on each side. That felt very vogue. Domain. Here's the first x value I'm using, left to right. Here's the last x value I'm using, left to right. So the domain is just between these two x values. That's a between inequality. -3 is less than or equal to x, which is less than or equal to 3. What's that look like in interval notation? Super easy. Bracket -3, comma +3, bracket, because we are those values. So it's nice, easy. It's between those. Between the inequalities, really easy to write in interval notation. Now remember that range is down to up. So the lowest down we go is -3. Highest up we go is -3. Same deal, except now since it's the range, it's a y in the middle. And here, you don't worry about what the variable is. You're just writing it as that interval. Even if they don't have arrows at the end, these computer model graphs we assume are going on to infinity here. This is a function. However, it is not one-to-one because it doesn't pass the horizontal line test. It passes the vertical line test just fine, but it doesn't pass the horizontal line test. So, is it onto? Are we using the full range, the full potential of range? And the answer is yes. This is onto. Okay, this is onto. We're using the full potential of range here. Okay, it's going on to infinity. It's getting bigger, it's getting smaller y value wise. The domain is still all real numbers, even though some, still going this direction. It's all real numbers, even though it's not one-to-one, is all real numbers for domain. And even though it's not one-to-one, it's still all real numbers for range. By the way, to make my fancy R, I just do 2 stalks on my R, my capital R, right? That's what makes it look fancy. This is a cubic function. We'll get into these a little bit later. All right. Last couple. That does not really have a type. It's just, let's call it a rhombus. Why not? I don't know for a fact. I haven't done a geometric coordinate proof on it, but it's looking rhombusy. We'll just call it that. That's not a type of relation or function. I just like the word. Not a function, though, which means not one-to-one and not onto. All right, what are we between? Looks like we're using -5 all the way to -1. So -5 is less than or equal to x, which is less than or equal to -1. And when you write that as an interval, it's -5, comma, -1 with hard brackets around both. Down to up, so -2 to 4. -2 is less than or equal to y, which is less than or equal to 4. And again, -2, comma, 4, hard brackets around it. Starts to get easy once you've done a couple, right? Ooh, parabola. Call it a quadratic function, should you so choose. It is a function. You wait till we have some serious fun with quadratic functions this year. It is a function, but it is not one-to-one, not passing the horizontal line test, and it is not onto, because it does have this specific stopping point in the range. Now, the domain, of course, is all real numbers. It's going both directions, infinitely increasing in both x directions. But the range comes up to this point and then back down, never goes up past this, never touches any y value that is greater than 0. So y always has to be less than or equal to 0, which means that negative infinity is where this guy is heading. That's the lowest number in the interval, and 0 is the highest number in the interval. Okay, so when you're making that interval notation, that negative infinity is on the left and the 0 on the right. Okay, you probably noticed on my screen, I'm almost done, I'm just trying to barrel through with you, right? You probably noticed on my screen that finally, they came and installed my emulator for me. I'm so excited. My emulator's back. These are nice Because here, the only thing I'm going to require you of work is to actually show me the substitution in. So this is my f of n function, and I'm going to put n equals 3. So all I have to write in is f of 3, because I'm substituting in a 3 for n, and I plug it in right there. That's all I'm really requiring you to write out work-wise. So now what you can do is go over to your graphing calculator, and you get to type in this line of work. 5 minus 3 is in 2 times 3 in parentheses. There you go. So you just type that line of work right in there and press enter, and you get -1. So f of 3 equals -1. That's my answer. It says show your work, which I showed you. I showed you the evaluate, the plugin. Then I got my answer. Now I just need to put it in an XY coordinate form. So the insert is the X, the answer is the Y, because the X is always the input and the Y is always the output. Let's keep going. H of 2. So it's 2 cubed plus 7. Got it. Well, I'm just going to plug that into my graphing calculator. 2 cubed plus 7. Okay, so 2 raised to the 3rd power, and then I arrow away, so I'm out of the exponent now. Oh, no! Plus 7. Let's just do it this way. There we go. I accidentally pressed enter too early, so I got to that 2 cubed first. But yeah, add 7 to that, you get 15. So this point is 2 comma 15. That is the most work I'm looking for there. Okay? It's the most work I'm looking for there. I did show you how to do those in the Delta Math quiz, so you'll know exactly what to do there. Okay, G of 16 equals a square root of 16. Well, boy, oh boy, I really hope you know this off the top of your head. It's because it's not a whole equation that you're taking the square root yourself. It's telling you just the principal root, so the positive. That would be 16 comma 4 as your point. If you're plugging that into your graphing calculator, it's a second, and the x squared gives you the square root, okay? So you can see that, so you know where that comes from. And of course, last but certainly not least, f of 7 equals 1/2 times 7 minus 2. Well, since I can't take half of 7 to get a whole number, turns out I'm going to get a fractional answer, which hopefully we are comfortable with, because we're going to see that a lot this year. Now, fractions are division problems, so the way that I type it into my graphing calculator is front parenthesis 1 divided by 2, and there's my fraction being multiplied by my whole number of 7. And then, of course, my -2. You know, I could have looked right at my screen right here. I'm looking at my other screen. That's why I'm looking off to the side, because it's more in your face than my laptop. Someday, if you're ever hybrid, you'll actually potentially see my setup in person. It's possible. It's possible. Here's hoping. And there we go. Now let's make that a point. 7 comma 1.5. Done and done. That is the review notes, where I really just went through a bunch of problems with you. More than happy to help you out. Just sign up for office hours. You have like all week next week to take your quiz, so that shouldn't be too much of a problem. I mean, I sign it Monday, but I don't close it until Friday. So I think you're going to be in good shape as far as that goes. And yeah, we've kind of finished off the lessons for chapter 1 next week. So yeah, cool. Okay, guys, good luck. Let me know if you need me. Sign up for those office hours if you need me. Email me, right? That's an awesome way to reach me. And I shall be seeing you. Oh, in the same outfit, because I'm doing this all day. Bye.